Hello everybody. I'm going to do this quick little video that's going to go over some of the sticking points on the guided lab for this week. If you're not having any problem, then great. If you are, hopefully this will help you. So for the first part, this first question, you just got to put in a guess. It doesn't matter what you do, as long as you put in a guess, then I'll give you credit for it. But on this next part, you have to do a little bit of digging. When you click on the link, it'll bring you to a PDF. It'll let you download a PDF that's similar to this one. The one you'll get is a little more up to date than this one is here. But you're going to go through and look at each of these regions. Region 1, 2, 3, 4 is down here, 5, 6. And you're going to tally the total number of floods and the total number of all disasters that have been declared by a United States president during that time span, and then you're going to calculate the percent of floods. So to do that, I'm going to go to Microsoft Excel because it's a little bit easier to do that. So I've already filled in 1 through 8. I'm going to go look at region 9, so that's this one, IX, southwest region here. And if you look here, the total number of disasters beside this pie chart is 52. So I'm going to put in 52. And then beside it, floods is 2. So I'll put in 2 there. And I'll show you that in a minute. Then region 10 is X. Total is 41. And the number of floods is 8. Okay, so now that I have everything in Excel, I can put in here equals number of floods divided by, in fact, I'm just going to show you this really. Go up here and put the number of floods divided by the total number of disasters, enter. And I have it formulated to give me a percent using the percent button right here. And then if you click on the fill handle, this little black square at the bottom, you can then click and drag that all the way down, and it will show you the percent for each region. And then in the bottom, it's asking for a total. And so you can click on this right here, auto sum, and that will automatically grab everything there and add it all together. Hit enter, or equally, you could just type in equals SUM, open parentheses, and then click and drag all of these cells, close parentheses, enter. And then you don't want to sum all of these because it would sum all the percentages and that wouldn't give you anything. But what you want is to get a percentage of the total, so we can do what we did before and just drag that down. And so you can see here that according to the data that I have, again, out of date poster here, so don't use this data, is 7%. And then what you can do, I guess I don't need these grayed out anymore. Then what you'll want to do is select all of these and copy, and then go back to the guided lab sheet and select all of these cells and paste them in. And it's as easy as that. So that's how you do that part. Let's go down to the part, where we are estimating cost of flood. So you'll click on this link here, floodsmart.gov/floodsmart, and it will take you to this website right here. And you click on flood risks, and then understanding your risk, the cost of flooding. It brings you to this page here, and then you want to click on this button. It says launch the cost of flooding. And after a little animation, it'll show you this screen here. And for this exercise, you'll click 1,000 square feet, and then you select how high you want your flood to be. I think in the guided lab, it asks you for 1 inch and 1 foot, or maybe it's 2 feet or something. Just to demonstrate, I'm going to select 4 feet, and it does this funky little animation for you and calculates An estimated cost of damage, $39,950. It's a lot of money. So the next part that we're going to talk about is this, the gauging station, this Fargo, North Dakota. And so you're going to go to the link above, which takes you to this NOAA website, which is the National Oceanic and Atmospheric Administration. And it brings you to this national map of all the river gauging stations throughout the entire United States. And you're going to want to click over here, roughly right around here. It doesn't matter exactly which one you click on because this is right near Fargo. So just click on one of those, any of them there, and it will zoom you in to the Fargo area. And it'll bring up a zoomed in map right on the border between Minnesota and North Dakota. And then the gauging station that we want is this one right here, right beside the F. When you click on that, it'll bring up this gauging station right here, the Red River of the North at Fargo. And this is a hydrograph. So what it's showing you here is this blue line shows where the river stage has been over the last few days. This dotted line shows you where it is right now. And then this line right here is the action stage. This is where the government will begin to take action to try to prevent flooding. At this stage, this is where they have determined that minor flooding is occurring on this river. So you're going to use this information to fill out the answer. So some of the questions that this asks you, for example, what unit is the river stage given in? Well, that is right here, right on the y-axis. You can see it right there. It asks you, what is the flood stage for the Red River at this gauging station? Well, you can see it right here where it says minor. You can also scroll down right here and you see different flood categories and what those are. Flood stage is shown right here in orange. The x-axis represents days of the week. What is today's date? You'll just put in the date that you're looking at this. And what is the stage of the Red River in Fargo, North Dakota today? That, like I said, is determined where right at this blue line where it intersects with the dashed line, okay? Then is the stage of the river, or is the river above flood stage? Tell where it's at there. And is the stage rising, falling, or remaining steady over the time shown on the graph? So from this point to this point, is this blue line going in a downward direction? That would be falling. If it's going in an upward direction, then that would be a rising stage. And if it's holding, if it's mostly flat, then it's steady. I would, in this case, accept either falling or steady in this case. It's falling, but very gradually. It's gone from 15.3 feet down to 15 feet. So not falling very rapidly, but I would accept either answer. And finally, this last one that I'm going to go over is looking at this graph here. The question asks, oh, excuse me, there's one more question here. The flood impacts on North Dakota. If you scroll down, all the way down past this map, then you see flood impacts photos. So this tells you at different stages what they will begin doing. So for example, this asks about 28, so I'll let you figure that out. But let's say the river gets to 36 feet. What does that mean? That means in Fargo, sandbagging starts if the river is forecast to rise above 38 feet. So it just tells you what types of actions will take place and how the flood will impact the area at different stages. Now this last one asks about this graph here. Okay, so this is for the same gauging station, and we've already collected the data for you, so you don't have to go collect all the data. All you really need to do to answer this question is go to Insert, Shapes, grab a line, and you're going to put a line right at flood stage. Go all the way across here. Any of these blue bars that touch or that intersect this black line at all, whether they touch it like this one or go above it, count those for this question here. And then you're going to either move this up or draw another one for the major flood stage. Remember, this is minor. You're going to draw another one at major, wherever that is. And again, you can find that in this website right here. And that's it. Let me know if you have any questions. There's several more things you'll need to answer, and I've covered hopefully all of those in the other video that I made. So good luck.